Hello, my name is Loo Zhi Xuen and I'm a third year student from SEAL, which is Electronic course. So I'm in the group 208, and this week we will conduct the laboratory, the instrumental laboratory, and which is the linear displacement measurement. So first I will be demoing the experiment 1 using the Tinkercad website. Okay, so for the first question, asked to simulate the resistor value. So the meter that have the internal resistor. So the first meter A is 10 kilo ohm internal resistor. The second one is 100 mega ohm, and the third one is the simulation meter. Okay, so here the reading of the resistor using the multimeter. Okay, go to the third question, which is we use the meter A connect to the figure 1.2 circuit diagram. So meter A, we have the 10 kilo ohm internal resistor. So this 10 kilo ohm internal resistor, for the third question, we will ask to turn the knob of the second potentiometer to the middle. So we just vary the R1 and check the reading of the voltage of R2. So I'll put it at the middle also for all the entire circuit that using the different meter that having the different internal resistor. So if I put it at the middle, I got this. My reading for the voltage VR2 is 4.62 volt. Okay, so come to the second, which use the meter that having the internal resistor 100 mega ohm. Okay, so I just varying this potentiometer and I put it at middle so that I can compare with the first circuit diagram that using 10 kilo ohm internal resistor. So for this, the result is around 5.49 volt. Okay, for 5.71 volt. Okay, so I'll show you the calculation. Okay, so if based on the calculation from like theoretical calculation, I got the value for the voltage of resistor 2, which not resistor 2, is VR2 is 5.7143 volt. If compared with the first one that having the 10 kilo ohm internal resistance, the reading is have a huge difference compared with this one. So the error, the percentage error of the 10 kilo ohm internal resistor is more higher compared to the meter that having the larger internal resistor, which is 100 mega ohm. So come to the third circuit that using the meter C, which is the simulation meter. Okay, we got the same value with this one, which is the 100 mega ohm. Why? Because we don't have internal resistor here, so when we do the simulation, the reading will actually the same with what we calculate in theoretical. Yeah, so come to the last one, which is using meter A and meter B together. Okay, so this is meter A, 10 kilo ohm internal resistor, and this is meter B, 100 mega ohm internal resistor. Okay, so I just varying this knob. Okay, I put it at middle. You can see when I varying this knob, both of the reading is the same because the reading will follow the result from meter A, because here actually this internal resistor, the 10k ohm internal resistor, would affect the reading of the whole diagram circuit. So, and this 100 mega ohm internal resistor meter won't affect the reading, which means more accurate. So means this the meter that having the larger the higher loading effect, no, the meter that having the highest internal resistor will be more suitable for measurement, because if we have the lower internal resistance, then the reading will be affected. As the conclusion, the meter B that having the higher internal resistance is more accurate compared to meter A that having the 10 kilo ohm internal resistance. Okay, so the higher the internal resistance of the voltmeter, the lower the current drawn from the circuit, thus the lower the loading effect. So means the meter will be more accurate.
Okay, for the experiment 2, the instruction given is to replacing R2 from 10k which is 100k, like figure 1.3, according to figure 1.3, like this. And instruction given to find the VR2 using meter A, meter B, meter A and B, and record the at least total 10 readings for each experiment and plot a graph. Okay, this is for our circuit according to figure 1.3. Okay, firstly the power supply we use is a 12 volt according to the question given. Okay, for this circuit we use switch for easy to measure the voltage VR2 when we change, or we want to change to the 10 different resistors, like question 1, to resistor for the potentiometer. Okay, firstly this is a meter B, which is have internal resistor 100 mega. This is meter A, which is has an internal resistor 10 kilo ohm. Okay, therefore for experiment we use meter A only. Okay, we use the meter A. Okay, firstly we must to check. Okay, firstly we turn off this and turn on for the potentiometer. Okay, we check. Firstly we have to find to 100 kilo for the potentiometer. How get the voltage? Okay, this is we set to the 100 kilo ohm, and we off me and on this for the voltage. Okay, we can get 12 volt. Okay, for the next resist value of potentiometer, which is 90 kilo ohm, and we can get the voltage 2.97, and we repeat for the next value 80, 70, 40, and until 10 kilo ohm to get the value. Okay, this is for meter A. Okay, for the meter B, the next question is meter B only, right? Okay, for the meter B, we firstly we delete it first. And we put for the meter B. Okay. Okay. Same method. Okay. Same method. Firstly we reset to 100 kilo and can get 12 volt. Okay. For the 90 kilo, the value for the voltage across R2 is a 3.95. We can see this is bigger than for the meter A, 3.95, and we also repeat 80, 20 until 10 for the meter B. Okay, for the next question, the instruction given for use A and B together, and we connect this like before. Okay, for the letter A and B we connect together and find the value. Okay, for 100 can get 12, same. Okay, for the 90 we get 2.97. It's the same result for the meter A. Mean the meter A and B together is the same result to only meter A. Okay, this is and we find to for the 10 different resistor to get a 10 different voltage, and that's all for experiment 2. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. My name is Mohd Sulaiman. I'm from group 208 from section 2. Today I'm going to explain and simulate the experiment tree from the experiment linear displacement measurement. Okay, from step 1, I've already constructed the circuit according to the diagram given, and then the second step, which is to adjust the 10 kilo ohm resistance in order to achieve 6 volt. This is the nearest to 6 volt that I've got. Okay, next I need to take 10 readings by adjusting the 100 kilo ohm resistance, and then record the voltage shown. Okay, first 10 kilo ohm, 6.07, 20 kilo ohm, 6.05 volt, 30 kilo ohm, 6.02 volt, 40 kilo ohm, 5.99 volt, 50 kilo ohm, 5.94 volt, 60 kilo ohm, 5.87 volt, 70 kilo ohm, 5.76 volt, 80 kilo ohm, 5.55 volt, 90 kilo ohm, 4.99 volt, and lastly 100 kilo ohm, 1.25 millivolt. I've recorded the experiment, and this is what I got. I've already placed in the table and then build the graph according to the result achieved.
My name is Salahuddin bin Muhammad Azan. Today I am going to show a demonstration for experiment 4 for lab linear displacement measurement. Okay, first of all, I'm going to show the experiment 3. From experiment 3, this is the circuit of figure 1.4a. We could see here this one. I'm starting the simulation. Okay, from here, the result is 6 volt as I already changed the potentiometer into the 6 volt as requested. Okay, now I'm going to show my experiment that I have done. Okay. The thing that need to be changed from experiment 4 is I need to use meter A. Okay, so I'm going to start the simulation. From meter A, the result is 4.8. They are slightly different from the meter, from the experiment 3. It is around 20% difference. Thank you. That's all from me for experiment 4. 5. I'm going to show a circuit using buffer with an 7441 operational amplifier as mentioned in the lab sheet. Okay. For now, I'm using meter C, so I'm going to start the simulation. The result is 6 volt. Now I'm going to change the multimeter with meter A. Okay, the result is also 6 volt. The next multimeter I'm going to use meter B. So I'm just going to change the resistance to suit the meter B. And still I'm getting the 6 volt. Okay. As we could see from the previous experiment 4, the result was 4.8 volt without the buffer. Using the buffer, the result will significantly change to 6 volt. That's all from me for experiment 5. Thank you.
Okay. Okay, for the experiment C is a measurement of speed. Okay. The instruction given is to draw the connection using a potentiometer and a DC motor and use a 12 volt input voltage as maximum voltage to the motor. Okay, so we construct the circuit for two motor in the circuit. First, we use a embedded motor, and the second, we use a normal motor. So we want to compare both who have a higher sensitivity and low sensitivity. Okay, firstly, we look for the embedded motor. Okay, we connect the potentiometer to the supply, and we use a amplifier in the middle to connect, because the question is to use a amplifier, so we use amplifier for this. Okay, we start the simulation. Okay, we can look for the motor. Sensitivity of our motor is 7 rpm for embedded motor. 7 rpm. Okay. This is for embedded motor. Let's look for the normal motor. This is for the normal motor. Same, we connect to the amplifier and potentiometer. Let's we see what happened for the normal motor. Okay, for the normal motor, we can look for the sensitivity is 27,271 rpm. Okay, let's compare for both. The embedded motor is 7 rpm and the normal motor is bigger than the embedded motor. Okay, so the sensitivity for normal is higher than for the embedded motor. Yes, we can conclude it. Okay, that's all for experiment C. Thank you.